Skype Academy presents Media Bypass in Cloud Connector Edition V2 by Carolyn Blanding. Training disclaimer. This is a point-in-time view. The session was recorded in July 2017, and the features and functionalities described here are current as of this date. Office 365 is an ongoing innovation. We constantly make changes, add new features and functionality. Please always refer to the latest trainings for updated information. Let me tell you a little bit about myself. My name is Carolyn Blanding. I've been with Microsoft for 5 years now. I am a Senior Supportability Program Manager and also a member of the Beta Technical Engineers in the Skype for Business Supportability Group. I'm also a member of the Extended Hybrid Voice team and have been working with the developers on Cloud Connector Edition since inception. Key learnings. Today, we hope to come away with the knowledge of how media bypass can improve quality and reliability, how improper network configurations can prevent media connectivity, and finally, that internally connected supported clients will always use media bypass. The scope of today's training is understanding media bypass in Cloud Connector V2. Prior experience is expected that you understand how to deploy and manage Cloud Connector. For more training on Cloud Connector, please refer to our training at the URL noted here. Plan for media bypass. In order to plan your network for media bypass, it's important to understand the media and signaling flows. Let's first take a look at media and signaling without media bypass. In this case, both signaling and media will flow through the mediation server. In this drawing here, the green lines represent the SIP traffic and the red lines represent the media traffic. We have a Skype for Business client connected to the internal corporate network. This client is making an outbound call. When the client starts the call, the signaling flows out from the client, out the external network to Office 365. And then the signaling comes back from Office 365 through the corporate firewall into the perimeter network to the Cloud Connector Edge server. From there, signaling flows to the mediation server, from the mediation server through the internal corporate network firewall to the SBC or gateway. The media traffic for the client will go from the client through the corporate internal firewall to the Cloud Connector mediation server in the perimeter network. From there, the signaling will then be transcoded and then will go outbound as G711 traffic through the firewall to the SBC or gateway. Now let's take a look at media and signaling with media bypass. In this case, the signaling will continue to flow through the mediation server, but media will go direct from the Skype for Business client to the gateway. Again, we have a Skype for Business client located on the internal corporate network who's making an outbound call, and the signaling is going, again, from the Skype for Business client to Office 365, from Office 365 to the Cloud Connector Edge server, from the Edge server to the mediation server, and then to the SBC or gateway. But we notice here that the media traffic is going efficiently direct from the Skype for Business client right to the SBC or gateway. And we have eliminated the connection point through the firewall here, the corporate firewall, to the DMZ or the perimeter network to Cloud Connector mediation server, and then back out from the mediation server to the gateway. So that's quite a few hops of network connectivity that we've eliminated by bypassing media. Benefits of media bypass. Why did we include support for media bypass? Well, as we saw on the previous slides, we can improve voice quality and reliability by reducing latency, possibility of packet loss, and the number of points of potential failure by allowing the media to flow directly from the client to the PSTN gateway. We can also reduce the number of CCE appliances because the CCE mediation server does not need to process the mediation transcoding from one codec to another. So we gain some efficiencies there, and thus we're able to support a larger number of voice streams on the same hardware. Network considerations. How to plan your network for media bypass. First, it's important to understand that when media bypass is enabled for a client, media will always bypass. This differs from Skype for Business on-premises deployments, where it is possible to configure Skype for Business so that media will bypass depending upon the client's network location in relation to the PSTN gateway. This is not the case for Cloud Connector. Cloud Connector Edition media bypass is always bypass mode. External connected clients and unsupported clients will never use bypass. Therefore, you need to account for the number of clients that will be connecting externally or using unsupported clients when sizing your mediation servers. Media bypass requires unobstructed connectivity between clients and PSTN gateways. If a media bypass enabled client does not have direct connectivity to a PSTN gateway, media connectivity will fail. We'll take a look at how that manifests itself later on. Media over VPN is not supported. This statement doesn't differ from our Skype for Business support statement. However, it's important to note that if you're going to block the media traffic in the media bypass story, you need to be sure you block all of the Skype for Business traffic from the VPN. If the signaling was able to go through and the media bypass sent back information to connect to the PSTN gateway directly, that connection would fail if media was blocked over the VPN. Our recommendation is that you block all Skype for Business traffic from VPN connections. Media traffic between the client and the gateway typically uses G711 codec. For inbound calls, the client is the mediation server, and mediation server will negotiate G711. For outbound calls, the client is the Skype for Business client, and the codec negotiated will depend upon what the gateway offers the client. Media bypass in a centralized CCE deployment. You'll need to consider that in this type of deployment, G711 media will traverse the WAN twice. We have Cloud Connector appliances located in one central data center, with local offices having local SBC or PSTN gateways for ingress and egress of calls. The centralized SBC associated with the Cloud Connector routes the calls to the local gateways. In this type of deployment, the G711 media traffic for the media bypass client will traverse the WAN 2 times. Once, when the client makes a direct connection for the media flow to the SBC that's associated with its Cloud Connector Edition deployment. And then second, outbound from the SBC through the same WAN connection in the office where the user is to the SBC or gateway, and from there out to the PSTN. Now let's look at a centralized deployment call flow when the user is connected to an external network outside the corporate network. We have a user from Zurich who's connected to the internet. The Zurich user places an outbound call. Both the signaling and media will flow to Office 365 through the external firewall at the Amsterdam site to the Cloud Connector deployment, through the internal corporate network to the Amsterdam SBC or gateway, and from there over the WAN to the SBC or gateway in the branch office in Zurich, and the media will flow out the local PSTN from the branch office gateway. Configure media bypass. In the next few slides, we're going to take a deeper look in how to configure media bypass for Cloud Connector. Configuration overview. Mediation Server Web Service. Each Cloud Connector mediation server has a web service to provide media bypass information that is configured as part of the V2 deployment. Summary of steps needed to configure media bypass. We will go over the details on each of these steps in the following slide. In summary, the administrator needs to define a URL to be used for the web service. The administrator needs to create a DNS host A record, an internal DNS service for this URL, resolving to the IP address of each mediation server. The administrator will enable media bypass using the Skype for Business Online PowerShell. Media bypass settings are then replicated to each Cloud Connector mediation server. And finally, internally supported clients will sign out and sign back into their Skype for Business client to pick up the media bypass settings. Web service URL. The administrator needs to define a web service URL for media bypass. Pick a name for the hybrid voice web service. That could be hybrid voice, media bypass, whatever suits. The name can be in any domain namespace that is hosted and resolvable in your internal DNS solution. This does not need to be in a domain namespace that matches the Cloud Connector deployment. Only one name is defined for the entire Cloud Connector deployment. We do not have a need for different names for different PSTN sites. An example of a name shown here is hybrid voice in the .contoso.com domain. Following is a sample of the web service URL. Your web service URL would be identical to the last section following the .com. Note also that the web service URL is HTTP. We chose to use HTTP to avoid extra administrative overhead. We are only returning the hybrid voice configuration information to internally connected clients. You will not be resolving this URL to external clients. DNS. In order for the clients to be able to contact the web service, they need to be able to resolve the web service name and resolve it to the IP address of the mediation servers that are hosting that web service. So we need DNS records resolvable to the internal clients, and we need to create one host A record resolving to the IP of the mediation server. And there needs to be a host A record for each mediation server deployed. For example, if you had 3 mediation servers deployed, you would need 3 host A records resolving to that web service name that you defined in the domain namespace where you're going to be hosting the service. It's our recommendation that you use GeoDNS to resolve local mediation server IPs based on the client location so that the client will connect to a mediation service closest to their geographic location. It's not a hard requirement, it's just a recommendation. Remember, there's going to be a single web service URL defined. There will not be separate web service URLs defined by site, so they'll all be the same name resolving to the IP addresses of the different mediation servers. Windows 2016 includes GeoDNS capabilities in the DNS service. If you have Windows 2016, you can take advantage of that enhancement to provide GeoDNS resolution for your Cloud Connector web service URL. Let's go through a sample configuration. First, you need to create DNS client subnets for each location. In our case, we have 2 locations, Amsterdam and Zurich, so we would create the 2 subnets related to their network locations. And then we would create DNS zone scopes for the hybrid voice domain for each location, one in Amsterdam and one in Zurich. And then we need to create DNS records in each of the DNS zone scopes for the respective mediation servers. So we would create the host A record in each zone with the hybridvoice.contoso.com name and target IP addresses of each of the mediation servers deployed in each location. And then finally, we need to create DNS policies that connect the client subnets to the matching zone scopes. For further details, please reference the vanity URL noted here to the online documentation for Windows 2016 GeoDNS. Enable Media Bypass in Office 365 Tenant. The tenant administrator manually enables Media Bypass using the new Media Bypass commandlets we've provided to manage Media Bypass in Office 365. To do this, you first need to sign into Remote PowerShell with the Skype for Business Administrator credentials. Then, set the web service URL that you had previously defined as we discussed in earlier slides. You do this using the set-cs tenant hybrid configuration commandlet with -hybrid config service internal URL specifying the full URL of your web service. Second, you need to enable the media bypass settings. This requires two steps. First, we need to create the bypass settings in memory, and second, we then need to modify the network configuration with these settings. Use a variable. In our example here, we're using media bypass to store the network settings. So $media bypass equals new-cs network media bypass configuration -enabled true. Then we're going to pass these settings we've stored to the set-cs network configuration with -media bypass settings $media bypass. After enabling media bypass, it's necessary to confirm the media bypass has been configured correctly. And let's take a look at how we can do that. First, we need to confirm the media bypass settings online. Sign in to Remote PowerShell with tenant administrative credentials. Confirm the hybrid configuration web service URL has been replicated to the local server store by running get-cs tenant hybrid configuration space -local store space pipe space select hybrid config service internal URL. We're piping out to a specific select because we really only need to see the config service internal URL setting. This will return the URL that you configured when setting up media bypass in your online tenant. Then you want to confirm the media bypass settings have been replicated to the local store. In this case, we'll use a get-cs network configuration -local store, pipe that out to a select -expand property media bypass settings, so we get a full listing of the media bypass settings configured. There are two settings that we want to look at here. One, that media bypass has been enabled. Enabled should be set to true. Second, take a look at the bypass ID. This is the bypass ID that clients should be receiving when they get enabled for media bypass. It's different than the online media bypass ID that they would receive otherwise. Please also note that the Media Bypass ID in version 2 of Cloud Connector will be the same for all tenants and all users of Media Bypass in Cloud Connector. After confirming Media Bypass was replicated online, we want to take a look at our on-premise host CCE mediation servers to confirm that they've received the bypass settings. You will need to open Administrative PowerShell on each Cloud Connector mediation server and run get-cs network configuration -local store, select -expand property media bypass settings. Here we're looking for three settings. 1, enabled is true. 2, always bypass is true. And in fact, always bypass will be true on all Cloud Connector mediation servers. This is a static setting that is not being replicated from online, but rather set automatically on the Cloud Connector mediation servers. And finally, we should see the bypass ID that we saw on the previous slide. Again, this will be the same for all Cloud Connector Edition mediation servers. How can we confirm that media bypass is actually in use? One option we have is configuring Performance Monitor on Cloud Connector mediation servers to monitor LS mediation inbound and outbound calls for total media bypass calls. In the sample I have below, I actually had active media bypass calls monitored because I wanted to watch them actively, but you don't need to do that. It depends. This works well for basic inbound and outbound calls, but it won't capture statistics on more complex calling scenarios like transfers between internal and external calls. But still, it's good to get an idea of how many calls in your environment are actually bypassing media. Second, you can tell by performing a network trace during a call. We'll be able to see if the client is making a direct connection to the gateway. In the sample below, the client is 123, 10.10.10.123, and the gateway is 10.10.10.8. Media bypass is enabled, and we can see that the RTP traffic is going direct between the client and the gateway. If media bypass was disabled, we would not see this traffic between the client and the gateway. Instead, we'd see the client connecting to the mediation server and then the mediation server connecting to the gateway. Confirm media bypass in calls. We can also confirm that media bypass is in use by looking at our tracing logs. We can search for A equals X-bypass in the Messages tab when opening a tracing log in Snooper. In mediation server tracing, there should be 3 items per call. Invite SDP will show 2 occurrences of A equals X-bypass ID with our Cloud Connector bypass ID starting with 2CD. The 183 session progress SDP will show A equals X-bypass, as will the 200 OK. Additionally, the VQ report in the client UCAPI log will show mediation server bypass flag as true. In this next section, we'll take a detailed look at media bypass in clients. How do clients obtain media bypass settings? Well, let's take a look at supported clients. When a supported Skype for Business client signs in, it retrieves the web service URL during in-band provisioning. This is the web service URL you defined in your Office 365 tenant. Then the client resolves the host name in DNS for that URL. Then the client will attempt to connect to the web service URL at the IP address of the mediation server returned in DNS. If the connection is successful and the client is running a supported version, bypass will be enabled with the following settings. Bypass enabled equals true, and a bypass ID equal to that of the Cloud Connector Edition bypass ID starting with 2CD. If the connection is unsuccessful, media bypass will be disabled. Note that if clients are connected via an external network, they must not be able to connect to the media service bypass service URL. If they were able to connect and they were enabled for media bypass, we would have media connectivity issues because that client is connecting through the external edge network and does not have direct access to the internal corporate network PSTN gateways. Troubleshooting obtaining media bypass settings in clients. You've deployed Cloud Connector V2 and enable media bypass in your tenant, but your clients are not making media bypass calls. How do you troubleshoot? Well, first, you need to confirm that the Skype for Business client is retrieving the hybrid voice URL during inbound provisioning in the sign-in process. You can do this by opening the link UCAPI log located in the local app data folder for the user at the URL specified here. Open this file in Snooper and then search for hybrid config in the tracing tab and confirm the URL matches the one you configured in your tenant. Let's take a look at a local tracing log for a user that is connected to the hybrid config voice service. So in the tracing tab, we search for hybrid config, and we can see here that during the inbound provisioning, the client did in fact retrieve the hybrid config service internal URL that we configured in our tenant. Next, confirm that the client can resolve DNS for the hybrid config name. In this case, you'd want to do a ping against that hybrid config name and confirm that an IP address of the mediation server is returned. You should also, and I didn't note it here, confirm that the client can actually connect to that mediation server at that IP address. Then, perform a web traffic trace during client sign-in to confirm that the client actually makes a successful connection to the mediation server web service and that it retrieves bypass-enabled true settings with the bypass ID of the Cloud Connector mediation server. Please see the previous slide for details on that. In the next slide, we're going to do a demo of a web capture during client sign-in. For this demo, we're using a tool called Charles. You can also use Fiddler. Let's take a look at a supported Skype for Business client sign-in process. Let's first take a look at the build number. We can see here that the build number is greater than our supported build number of 7870.2020. Next, let's take a look at the IP config information to confirm the client is connected to the corporate network. And it is. It has an IP address of 10.10.10.141. Now, let's sign in while taking a trace of the web traffic. We can see that the client has connected successfully to the web service URL and has received a response. And in that response, we can see that bypass enabled equals true. And we can also see that the client received the bypass ID of the mediation server bypass ID address starting with 2CD. Now that we've confirmed that the client is enabled for media bypass, let's make a call and confirm that the media traffic is flowing directly between the client and the gateway. First, let's take a look at the IP address of both the client and gateway. The client's IP address is 10.10.10.123. The IP address of the SBC gateway, SBC01, is 10.10.10.8. The call is established, and we can see that we have media flowing directly between the client at 10.10.10.123 and the destination at 10.10.10.8. That's the gateway. So media is going directly between the client and the gateway. Let's take a look at our client-side logging for this media bypass call. I've opened our link UCAPI log file from the tracing folder in Snooper. And let's look at the invite out from the client. So take a look at the STP here, the content type, application STP. This is from our client at 10.10.10.123. And if we look here at the bottom of the STP, we'll see A equals X dash bypass ID with our mediation server bypass ID. And if we go down to the 180 ringing, we will see the gateway STP of 10.10.10.8. And finally, let's take a look at our service out record here for our VQ report and take a look at our local user agent here. And we can see here from our client agent, that's our client version, that the mediation server bypass flag is true. What about unsupported clients? What happens when they sign in? Well, for the Windows Desktop 2013 and Skype for Business clients that are not running supported versions, the client will attempt to make the connection to the service URL. The CCE service will check the client version, and if it's unsupported, disable media bypass. The media bypass enable flag will be set to false. For all other clients, that would include Link 2010, mobile, Mac, and phone devices, these clients do not have logic built into them today and will not attempt to connect to the web service URL, and media bypass will be disabled. Now let's take a look at when an unsupported client signs in. This is a Skype for Business, or aka Link client, running as part of Office 2013. It's click to run, but it's of a build prior to our minimum supported build. Let's sign in and see what happens. We can see that the client has successfully connected to the web service URL over here. We have gotten back a 200 OK. And if we go to the contents, we can see in the response that bypass enabled is false, and that is because we're running an unsupported build of the Skype for Business client. Client media connectivity failures. You've implemented media bypass, and now some of your clients are having call failures. What is a symptom of a media connectivity failure? Well, in this case, the call rings, but the client shows connecting call, and it fails to connect, and neither party can hear each other. This indicates that the client's able to get signaling through the mediation server, but that the media that's bypassing the mediation server is failing to connect to the PSTN gateway. Well, how can we troubleshoot this? Well, first, confirm if the client and the PSTN gateway can actually reach each other over the network. Most likely they can't. If they can, you'll need to take a deeper dive. You could try one of several things. 1. Collect logs on the Cloud Connector using the CCE host commandlets. You would do this from Cloud Connector host administrative PowerShell and run start-cc logging to start the CLS logging scenario of inbound and outbound calling, which runs for 4 hours. Repro your scenario and then run the search-cc log. You will need to provide start time, end time, and file name for the output. When the search is completed, the file will be located in the log folder off the appliance root on the host computer. You could also look at the invite in the SCP client logs and confirm that the IP offered matches that of the client network IP. We've made resolutions to how things work, and this should not really be an issue anymore, but in previous builds it could have been. Perform a network trace to determine where the traffic failure is. And then finally, review your gateway logs, which may give some further information. Perhaps there's actually a failure on the gateway that is causing the issue and not something on your network. And that concludes our training for Media Bypass and Cloud Connector. I will now just go over a few wrap-up items. Key learnings for this session. 1. Media bypass can improve quality and reliability by removing latency and points of failure. Improper network configuration can prevent media connectivity. We looked at one scenario and we talked at many of the considerations that you need to make when planning for media bypass. And very important, internally connected supported clients will always use Media Bypass when they make a successful connection to that web service URL. Media Bypass will be enabled with the same bypass ID for all clients, no matter where they're connected on your internal network. Those clients must have good connectivity to PSTN Gateway, or the media connectivity will fail. Please note that we have listed some resources here for your reference. Our Skype Operations Framework website, our Skype Operations Framework Academy, where you can find trainings. Please always refer to our training section for updated training material. Please visit Skype Feedback and keep your feedback coming. We rely on the feedback we receive from our customers in deciding how to make improvements to our features. And finally, please visit SkypePreview.com, where you can sign up for TAP, Super TAP, or Preview programs so that you can be on the early release builds to help review those features before they go GA. Please visit our community to discuss, ask, and provide feedback. You can stay up to date with the latest trainings and other information at our blogs. Thank you. Have a great day.